Topic 8-1 in probability is learning about counting outcomes. An outcome is any of the possible results of an action. So when you roll a number cube, you can have the outcome of a 1, 2, 3, 4, 5, or 6. Those are all the results. An event, one outcome or a collection of outcomes is called an event. The sample space is a list. It's an organized list of outcomes. You should be familiar with sample spaces from last year. Now, one way of demonstrating a sample space is using a tree diagram. So here's an example of a tree diagram. Looks like we have a scooter, and the scooter comes in several different colors, silver, red, or purple, and several different wheel sizes. And so this is our tree diagram, and then this is the example of the sample space over here. So you can see here that the silver scooter can have either 125 millimeter wheels or 180. So our sample space, we have silver 125, silver 180. Then we can have a red scooter, red 125 or red 180. Purple 125, purple 180. The fundamental counting principle is a way to find the total number of outcomes. And all it's saying is that if you multiply the possible outcomes of one event by the possible outcomes of the second event, you can find the total number of outcomes. So if we want to find the total number of outcomes when a coin is tossed and a number cube is rolled, well, the total of outcomes on one coin would be 2, heads or tails, right? The total of outcomes on a number cube would be any number between 1 and 6. So there's 6 possible outcomes there. So if we toss a coin and roll a number cube, 2 times 6 equals 12. And 12 is your total number of outcomes. So you multiply the outcomes in one event by the total number of outcomes in a second event, and you have the total number of combined outcomes. So probability. Probability is the ratio of a specific outcome to the total number of outcomes. So the specific over the total. So the probability of rolling a 6. The probability of rolling a 6 would be 1 out of 6. Because there's only 1 6 on a number die or a cube, and there are 6 total outcomes. So 1 in 6, the probability of rolling a 6 on a number cube. If each outcome is equally likely to occur, it's called random. So a random outcome, like flipping a coin, spinning a spinner, rolling a number die, those are all random things. There's nothing that affects what number is going to pop up or whether it's going to be heads or tails or what color ends up on the spinner. So let's look at some quick examples. So a museum tour includes a lunchbox which contains ham, turkey, or cheese sandwich, an apple, banana, orange, or pear. An equal number of all lunch combinations are available for every tour. Draw a tree diagram to determine the number of outcomes. Go ahead and do this on your own, and then you can push play and come back and double check your work. So we have our lunch. And you can choose from 3 different sandwiches. You can do ham, turkey, or cheese. And each sandwich would come with an apple, a banana, an orange, or a pear. Apple, banana, orange, pear. Apple, banana, orange, pear. So nobody says that you can't get a ham sandwich with a pear. You can get it. You can get all the different sandwiches with any fruit. So This would be our tree diagram for the total number of outcomes. How many outcomes are available? For our total number of outcomes, all you have to do is count the outcomes on the bottom. And since we are all math gurus, if there's 4 outcomes and there's 3 sets, 4 times 3, there's 12 possible outcomes. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, number 2. Says use the fundamental counting principle to find the number of possible outcomes. So a number cube is rolled twice. So the possible outcomes with one roll is 6, and we're doing 2 rolls. So we multiply by 2, and we have 12 possible outcomes. And number 3, 6 coins are tossed. If we toss 6 coins, go ahead and work that one on your own. Pause it, come back to check your work. Okay, there are 2 possibilities for each time the coin is tossed. It's tossed 6 times. So again, we have 12 possible outcomes. And that is the end of the number theory of counting outcomes.